Today I shall discuss the compounding of steam turbine. The compounding of steam turbine. The compounding of steam turbine. What is compounding and why it is used? Now consider this is not a compounding, that is a blades and a nozzle. The steam from this nozzle impact the turbine blade. That's mean it having the single blade only. This is not compounding, because if the steam impact on the blade, then the turbine will rotate higher speed, that is heavier speed, and by the single impact of the steam which impact on the turbine blade, that suddenly the blade will rotate very high speed, that causes the damage of the blade. But if we produce or arrange numbers of blades and this steam partially impact the first stage of the turbine blade first, then if it go to the second blade and third blade again, then what happen? The high velocity steam cannot directly reduce to a single blade only. That's why the blade corrosion and erosion and damage of the blade will reduce. And this is the shaft which will rotate by partially movement of this steam which move partially and causes the reduction of this velocity of the steam, and therefore the reduction of the turbine speed causes the compounding. That's mean we cannot directly impact on a single blade to produce the speed of the turbine, but if you apply this steam through the numbers of blades in a row, then what happen? All the blades will act and the speed of the steam will reduce gradually. The speed of the steam can be shared by all these blades. The speed of the steam will shared by all the blades. Therefore, the damage of the blade will not occur and turbine speed gradually reduce. These types of reduction of the speed is called the compounding. Now I am writing what is compounding. The reduction of speed of the turbine in gradual steps is called compounding. You can see that the reduction of speed of the turbine, that is the reduction of the speed of the steam. This is the reduction of speed of the steam. Okay. This compounding can be one, velocity compounding or pressure compounding. This may be velocity compounding or pressure compounding. Now the speed of the steam which passing through this, the steam which is passing through these rows of the blades and it having some pressure and velocity, this pressure can be reduced in gradual step or velocity can be reduced in gradual step. If the velocity is reduced in gradual steps, then this types of compounding is called the velocity compounding. If the pressure is reduced in gradual steps, then this type of turbine is called the pressure compounding turbine. Okay. Now, first of all, I am starting the velocity compounding. Velocity compounding. I already discussed that in this velocity compounding, the blades are arranged such a way that the velocity will reduce gradual steps. Okay. So in this compounding we reduce the velocity of steam in gradual steps. Now these types of compounding where velocity is reduced in gradual steps, this type of turbine is called the Curtis turbine. Now first of all I am drawing the velocity compounding diagram. Now you know is having numbers of blades, so I am producing the rows. Now first of all we know there is the nozzle through which the steam can pass. This is a nozzle. Then moving blades, that is moving blade. Then it will be fixed blade, that is fixed blade. Then further it having moving blade. Now you know in the nozzle, when the steam pass through the nozzle, the velocity, when steam pass through this nozzle, the velocity at the end of the nozzle will increase. So I can increase the velocity and pressure will reduce. As the velocity will increase, the pressure obviously will reduce. Now when this is the pressure and this is the velocity. Okay. Now when this steam pass through the moving blade, what happened? This velocity will reduce. Velocity will reduce. Why the velocity will reduce? Because the moving blade will rotate. It will rotate. And therefore the velocity will reduce. And you know the cross section, here cross section of moving blade when it is impulse turbine, this blade is is half moon like that, there was the cross section will be same. That's mean the cross section here, this cross section and this cross section will be same. Therefore, the pressure will be remain constant. Now, when this velocity pass through the steam pass through the fixed blade, what happened? The velocity will not change. That's mean it will remain constant because the fixed blade is fixed, not rotating. Therefore, the velocity at inlet and outlet will be same. Okay, velocity at inlet and outlet will be same. So therefore, this is constant velocity. And as the velocity is constant, pressure obviously will be constant. After that, what happened? The velocity further, the steam further pass through the moving blade. That's why it will further reduce and pressure will remain constant. This end may touch each other, this line may touch each other or not. Okay, so these types of compounding is called the velocity compounding. You can see that the velocity is gradually reducing here and further here. Okay, but pressure is constant, not changing. So this type of turbine is called the velocity compounding. Okay, now further, these types of turbine is called Curtis turbine. This type of turbine where velocity compounding is there is called the Curtis turbine. Okay, now I am going through the pressure compounding. Pressure compounding. In the pressure compounding, the pressure will reduce gradual step, not velocity. Here you can see that for velocity compounding, the velocity is reducing in gradual steps. But in case of pressure compounding, you have to arrange the blade in such a way that pressure will reduce gradual steps, but velocity may change or not, but pressure will change gradual steps. Now for this case, what is pressure compounding? In this compounding, we reduce the pressure of steam in gradual steps. Now I am arranging the diagram for this case. In this case, we have to arrange initial. We know for reaction turbine, I am arranging the reaction turbine blades at initial. The reaction turbine blades look like that. You can see that this is the impulse steam turbine blade, but I have arranged for pressure compounding through the reaction turbine blade. Initially, it will be the reaction turbine blade. Further, you can arrange the reaction turbine blade. You can further use reaction turbine blade. You can further use reaction turbine blade. All are the reaction turbine blade. I have arranged this pressure compounding in such a way that all are the reaction turbine blade. This velocity compounding having the impulse turbine blade. That's all are the half moon like that. So this is the impulse turbine blade. But in case of pressure compounding, we have arranged this by the reaction turbine blade. Okay. For this case, you can see that for reaction turbine blade act as a nozzle, so velocity will increase and pressure will reduce. It will act as same as the nozzle here. This will be act as a same as nozzle. The reaction turbine blade act as a nozzle. So this is the velocity and this is pressure. Now you can see this is the fixed blade, this is the moving blade, this is the fixed blade, this is the moving blade. Now if the steam pass through the moving blade, we already know the velocity reduce and pressure also reduce in the moving blade when it is reaction turbine. Reaction turbine means it will act as the turbine blades act as a nozzle. So in the nozzle we already know the pressure will reduce, that is the pressure will reduce. Now at the fixed blade, what happened? At the fixed blade, when it is nozzle, the velocity further increase, but pressure will reduce because it is nozzle. The reaction turbine blades act as a nozzle, so pressure will reduce but velocity will increase. In the nozzle, velocity will increase and pressure reduce. Further, when it is moving blade, what happened? The velocity reduce and as it is nozzle, it will act as a nozzle, so further pressure will reduce. You can see that in this case the pressure is gradually reducing and velocity is in the fixed blade increasing and the moving blade reducing. Fixed blade increasing, moving blade reducing. So these types of turbine is called the pressure compounding turbine, and when the turbine is arranged with the pressure compounding, then this types of turbine is called the ratio turbine. So these types of turbine is called ratio